Have you ever imagined that a ship could sail over mountains? And this isn't like something out of a movie or a dream, it's a reality. You can turn your fantasies into reality. And to do so, you must come to China. In the modern world, all of this is only possible thanks to dams and hydropower systems. Approximately 1/3 of the world's installed hydropower capacity comes from China. This is not surprising, as there are countless hydropower stations in the country, some of which have even set world records. For example, in China there is a dam called Baihetan, one of the largest hydropower stations on our planet, with an installed capacity reaching 1 million kilowatts. Its scale is enormous and its annual power generation is truly remarkable. Although its installed capacity is lower than that of the Three Gorges Dam, it still ranks as the second largest hydropower station in the world. In fact, the world's top 5 hydropower stations are all Chinese projects. In this country, people can actually make ships sail over mountains. In today's video, you will learn how Chinese engineers accomplished this feat. They used ship lifts to turn fiction into reality. This is the Goupitan Hydropower Station, where the dam stands 232.5 meters tall, and the total lift height of the ship lift reaches 199 meters. Equivalent to 66 stories. Ships are raised in 3 vertical stages to bypass the dam, traveling directly from the lower to the upper reaches of the Wujiang River, making it one of the world's largest ship lifts. So, how does this ship lift actually operate? First, a 500-ton vessel enters a gigantic ship-carrying chamber measuring 40 meters in length and 12 meters in width. The chamber is flooded with water to create a moving waterway. It is towed by 256 steel cables and is raised and lowered vertically via a gear rack climbing system, with each stage taking about 30 minutes. The ship must ascend through 3 levels of the ship lift, taking a total of approximately 2.5 hours, reducing the journey by 4 days compared to traditional winding mountain routes. Employing a world-first gear rack plus nut column safety system that can withstand an 8-level earthquake in extreme wind and waves, the lift's precision is maintained within plus or minus 10 millimeters, ensuring that 1,000-ton class vessels can traverse the mountains smoothly. This project has restored full navigation along the Wujiang River, opening up the golden waterway that connects Guizhou to the Yangtze River, increasing annual freight capacity to 5 million tons, and boosting the development of the Central Guizhou Economic Zone. The International Shipping Association has even described it as redefining the possibilities of inland navigation. Now, observe a ship sailing along a canal that, upon approaching a tall building, enters its interior. Inside this structure, a lifting cable hangs, flanked by 2 rows of drums and gearboxes on either side. To residents of a typical multi-story building, such an elevator might seem both incredible and sluggish, given its enormous internal footprint. However, the designers claim that this ship lift can raise and lower a 500-ton vessel in about 10 minutes. In other words, a standard passenger ship can easily depart from its original position in such a short time. The massive lift has a maximum load capacity of 18,800 tons. Even though a vessel might take a bit longer to be fully raised, hardly anyone cares because any waterborne vehicle will be lifted to an astonishing 72-meter height. Incidentally, this height can vary depending on the downstream water level, with a maximum lift of up to 200 meters. Some have even called the ship lift system at the Goupitan Dam an incredible feat of engineering. Of course, such praise is open to debate, since ship lifts have been implemented in various parts of the world for some time. However, you will notice that this system does not consist of a single elevator, it actually comprises 3. Following the first elevator is a second one that raises vessels to a height of 130 meters. Its operating principle is straightforward. The ship enters, waits for the system to activate, and is then raised as a whole. Through the Goupitan Dam's lift system, the water surface of the entire shipping channel is elevated to 199 meters, simply unbelievable. To put this in perspective, the height to which a ship is lifted is equivalent to that of a 66-story building. If you were near the Great Pyramid of Giza, you'd see that its height is 139 meters from above, while the Statue of Liberty in the United States stands only 93 meters tall. This makes one truly admire the ingenuity of Chinese engineers, as a lift height of 199 meters is almost unimaginable. Under normal circumstances, a river with such a dramatic elevation drop would be non-navigable. Yet, through advanced engineering techniques, the Chinese have achieved this astonishing feat, earning them the well-deserved nickname Infrastructure Maniac. Moving on, after a ship passes through two of the elevators, it must then be lowered in some way to reach the water behind the dam. To accomplish this, the system includes an additional elevator at the end of the mountain route, with a maximum lowering height of up to 47 meters, again, depending on the water level. Incidentally, in terms of throughput, this system might appear rather rudimentary. Although the ship is raised relatively quickly, it can accommodate only one vessel at a time, meaning that the elevator system's capacity is not very high. In fact, it might even lead to long queues waiting for the elevator. However, once one ship passes through the first elevator, the next can immediately be raised. While this arrangement is not perfect, the design engineers have done their utmost to expedite transportation along this single route, comprising 3 elevators and a section of water conduit. The system makes elevation changes extremely simple and undoubtedly represents yet another astonishing achievement of Chinese engineering. There remains a certain distance between the elevators that must be traversed, but in this case, it poses no significant challenge. Traditionally, locks are used to transfer vessels between different elevations without needing to cross mountains. Multi-level elevation changes are typically achieved by installing several locks that slowly raise or lower a ship step by step. However, here the vessels must navigate among mountains. Initially, there was no river beneath the elevator system at all, so in addition to constructing the 3 elevators, another feat had to be accomplished, laying a passage between them. Ultimately, the main passage between the 2 elevators and the mountain is an open water conduit. This does not mean that building such a passage is uncommon. Ancient engineers achieved similar feats without modern high-tech. But in this case, integrating the waterway system with rugged mountain terrain and the entire elevator system greatly increased the challenge. Nonetheless, Chinese engineers successfully overcame these difficulties, completing the second mountain crossing route. In fact, you need not even wonder how China managed it. The country has accumulated considerable experience in tunnel construction, using giant tunnel boring machines to excavate tunnels so that everything is completed as planned. As a result, a mountain route spanning 2.3 kilometers was born. The entire project cost a staggering $7.775 billion, and it is precisely because of this ship lift system that vessels are able to traverse the most perilous terrain. If a more traditional lock system were used, each ship would undoubtedly encounter far more difficulties during its journey. You may have already realized that the water conduit and elevator system were built specifically because the Goupitan Dam is located in this region. This ship lift system is one of the fundamental supporting facilities of the dam. In summary, the Goupitan Dam and its hydropower station are not particularly remarkable in themselves. The only unique aspect is their highly advantageous navigation system, which allows ships to effortlessly fly over mountain ranges. This raises another question. Why did China need such an enormous investment, consuming vast amounts of effort, time, and capital, to build this system, especially when the project itself doesn't seem all that grand? First, let's take a look at the location of the dam and its navigation system. For ships, this area is narrow and environmentally harsh, to the extent that using a traditional lock system was simply not feasible. It's worth noting that after the completion of the Goupitan Dam, Chinese engineers undertook significant work overall. Building any dam creates a barrier in the river, causing water to accumulate on one side and leading to a rise in water levels on the other. Although in some places, this difference in water levels might not be very noticeable. In the case of the Goupitan hydropower station, the water level difference is so immense that designers had to abandon a single ship lift system, as lifting ships in such a manner would not only be time-consuming but also extremely dangerous. Therefore, constructing a dam and hydropower station in this context became essential, even though the project itself required enormous labor and substantial costs. Therefore, to both develop new energy in the region and establish a water transport network, Guizhou built the Goupitan hydropower station and its ship lift system, which has an annual cargo capacity of 2.928 billion tons. Some might argue that using semi-trailers or rail cars to transport goods is also feasible, but these methods are less efficient. For example, a standard truck can carry about 23 tons, while the Goupitan Ship Lift can hoist a 500-ton ship, and this is not even the limit. In fact, a single barge can replace dozens of trucks. Considering the road construction in Guizhou's mountainous areas, it is nearly impossible to build wide highways suitable for large numbers of small trucks and tourist vehicles. Allowing trucks to navigate narrow mountain roads and bridges poses significant risks. Since water transport exists, and barges and other cargo ships are more fuel efficient, rail transport, while slightly better, faces its own challenges, such as the difficulty of laying tracks and the overall lower efficiency of rail freight compared to water transport. Despite the various challenges associated with the ship lift system, this region has achieved the optimal solution through massive investment. As a result, we are able to witness such a spectacular sight and understand how real it is to sail ships through mountains. After all, a ship lift capable of hoisting 10,000 tons is itself an incredible feat of engineering. The completion of this engineering project has left a profound impression on netizens abroad. Many remarked, "The ship lift alone is jaw-dropping." This navigation channel built on the towering bridge of the Goupitan hydropower station is a world-class aquatic viaduct with design and construction quality that's simply mind-blowing. And the water tunnel cutting through the mountains, that's pure genius. China achieves such incredible infrastructure for less than half the cost of a single Arleigh Burke-class destroyer, all while maintaining navigation on a major river. What a bargain! Others added, projects like this feel almost routine for China, yet they're engineering marvels. If this were in the US, it would take roughly 50 years to plan and another 50 years to build, if it ever got done at all. While some comments may be exaggerated, they undeniably reflect the staggering capabilities of China's modern engineering prowess. Let's take a look at the ship lift at China's Three Gorges Dam. This lift system can hoist ships weighing up to 3,000 tons, completing a round trip in just 40 minutes, numbers that are staggering on their own. As the saying goes, with great power comes great size. The lift's chamber measures 122 meters in length and 18.3 meters in width, holding a volume of water equivalent to 4 Olympic-sized swimming pools. Its colossal scale allows it to accommodate nearly any vessel at maximum capacity. Imagine lifting a ship of such immense weight to a height of 113 meters above the ground. It's an almost unbelievable feat, but it must be pointed out that raising such an enormous weight to a sufficiently high altitude with a single lift is in itself an extraordinary achievement, and we cannot overlook the brilliant ingenuity of Chinese engineers. Chinese engineers have also put a great deal of effort into safety. They have installed 4 sets of symmetrically arranged drive mechanisms, equipped with gears and supports that firmly reinforced the 4 corners of the ship's cabin. This setup effectively eliminates the adverse effects caused by the tilting or swaying of the water inside the cabin, and it greatly reduces the risk of capsizing. The designers have also ensured that even in emergency situations, such as during an earthquake, the system remains safe, because the lift cabin is equipped with cushioning devices that absorb vibrations and shocks. A construction expert involved in the project highlighted the seismic protection system. It dissipates seismic forces across multiple support pillars. This design prevents chamber collapse and other catastrophic failures. Since the commissioning of the multi-stage lock system at the Three Gorges Dam, its benefits have already begun to emerge. According to media reports, the dam's cargo throughput reached 100 million tons in the first half of 2024, marking a 10.32% year-on-year increase and setting a new historical record for the Three Gorges locks. As you might expect, before the ship lift became operational, vessels still needed to traverse the dam, a process enabled by another engineering marvel, the 5-stage lock system. Installed adjacent to the dam are 2 parallel lock complexes, each consisting of 5 chambers, with a total transit time of approximately 4 hours. This time gap, 40 minutes versus 4 hours, is precisely why China is prioritizing the construction of a new lock system. Such delays could severely impact individual businesses and even the broader Chinese economy. given that the Yangtze River serves as a critical maritime artery with no viable alternatives. But just how impactful are these locks? Even with a 4-hour transit per vessel, the dam's annual cargo volume hit 180 million tons in 2024, and this figure continues to grow alongside China's economic expansion. Notably, initial projections estimated a maximum annual capacity of just 100 million tons, a number that has been clearly underestimated. With each mega project built, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments, and don't forget to subscribe and hit the bell. See you in the next video.